Hey, calculus students. This is the last lesson of topic 3, derivatives of inverse trig functions. Follow along with your booklet. I'm on the lesson page for topic 3, and we'll just finish the rules for the derivatives of inverse trig functions. First, I want to point out something about the rules for inverse sine and inverse cosine. You know, just like the derivative of sine x is cosine x, the derivative of inverse sine x is 1 over the square root of 1 minus x squared. But now that we've learned the chain rule, the inside part of every function that we work with could be something other than x. So that's why we use the variable u to represent whatever that function is and multiply by du dx, because that's what the chain rule says. Then same deal with arc cosine or cosine inverse. The derivative of cosine x is negative sine x, and completely different but same style, the derivative of inverse cosine x is negative 1 over blah blah blah, what you see there. The rest of the rules are written there for you, so you could pause the video and jot them down, but I just want to point out that the derivative of arctangent is nice and clean, multiply by du dx, the chain rule, but the derivative of arc cotangent is simply the negative version of that. Same idea as secant and cosecant, but those derivatives are pretty crazy, so we don't do too much with them. So for secant inverse and cosecant inverse, we'll just try our best to calculate the derivatives using the rule and do a little algebra in between. The examples below are fairly straightforward. I'll just point out a few things. For example 1, y equals arc sine 8x squared. U is 8x squared. Therefore, we take the derivative of it. And the outside function is arc sine of u. Then down below, notice that since u is 8x squared, we have to raise it to the second power. So we actually get 64x to the fourth. For example 2, remember, secant's the crazy one. U is equal to 3x minus 4, so we really could just do that in our heads. We don't have to write all that out, what u is and du dx. So that's what that 3 is there for. And then the u is plugged into the absolute value as well as the square root, and that's being squared. So like I said, we do a little algebra in between here, and that algebra is mainly just squaring that 3x minus 4. And remember, that's a binomial, so you end up getting 4 terms, or just using the FOIL method. And for example 3, cotangent inverse of x squared, again, we can tell what u is just by looking at the equation. So that's why I wrote du dx on the side there is 2x, and we're not doing substitution. So I'm training you to start thinking about the chain rule in your head so that you don't always have to write it. It's kind of like when you solve equations by hand and you don't have to write the step that you're doing, you could just take the step. The last thing I want to do is point out a few things about the exercises. So if you still need to write down the rules or the examples, then pause now. The following exercises should be done before our next class. 1 through 3, we're skipping 4 for now, and 5 through 7. There's 1 or 2 more on the next page that I'd like you to have done, but I'll talk about those in a moment. Here are a few tips. Number 1 is a very straightforward use of the rule and the chain rule. Number 2, same thing, except just want to point out that that little t right there is not inside the square root. So that actually makes things easier. Number 3, very direct use of the rule, but we could rewrite 11 over t to the fourth as 11t to the negative 4. We're skipping 4 for now. It's a good challenge though. It's pretty interesting. Number 5, straightforward use of the rule. And notice that we can write t over 7 as 1/7. The answer to this question is just a number because we're plugging in 2. So as soon as you take the derivative, plug in 2. Don't simplify with any algebra. Number 6, very pleasant. Notice that u is equal to negative 3x. Again, we get a value because we're plugging in 2. Finally, number 7, remember, crazy secant rule. So you'll apply the rule and then simplify what's inside. On this page, we only did 2 exercises. Number 10, which For this question, the z is inside the square root. So rewrite that as 3, parentheses, 3z to the 1/2. Then take the derivative. The 4 in front of arctangent just sticks with the derivative. And we also did number 13. And the little hint for that is same as one of the previous questions, that x over 3 can be written as 1/3 x. So I'd like you to do 10 and 13, but not required for class on Tuesday. Okay, that's it. Now it's your turn. Keep doing calculus, and I'll see you in class.